The product of genome surveillance is ultra-long scaffold sequence. Each ultra-long scaffold sequencing read consisting of multiple linked and ordered next-generation sequencing reads, like this graphic shows. The green bar stands for next-generation sequencing reads. The dashed blue line stands for the gap between the next-generation sequencing reads. The size of the scaffold sequencing read ranges from 100 KB to several megabases. Therefore, it is very good for de novo genome sequence assembly and sequence finishing. You can directly align next-generation sequencing read and contig to the long scaffold sequencing read and compute the final genome sequence based on the sequence alignment. We can also use the scaffold sequencing for haplotype phasing. By next-generation sequencing, you can detect many genomic variants. However, for diploid genome, this genomic variant may belong to different haplotype. It is very difficult to phase out these genomic variants due to the limited length of next-generation sequencing read and contig. With scaffold sequencing, you can directly align these genomic variants to the long scaffold sequencing read to phase out these genomic variants. For example, the genomic variant 1, 3, and 4 can be aligned to the same long scaffold sequencing read, suggesting they belong to the same haplotype. Variant 2 and 5 can be aligned to the other long scaffold sequencing read, suggesting they belong to the other haplotype. Besides the use for de novo genome sequencing finishing, and haplotype phasing, scaffold sequencing can also be used for the detection of long-range structural genomic variation. By next-generation sequencing, you can detect relatively small genomic variants. However, it is very difficult to see the overall picture of the target genome structure and organization. By scaffold sequencing, you can use the long scaffold sequencing read to detect a large genome rearrangement, such as translocation, inversion, duplication, etc., in relative to reference genome sequence. There are also many other potential applications for this technology, such as high-resolution metagenomic disease diagnosis, biomarker discovery, and single-cell genomic, etc. Therefore, there are huge market potential for scaffold sequencing products. Thank you. Bye-bye.